Starting in the front of the tranny, the first thing we found was the overdrive clutch pack, completely burnt. Steels, clutches, totally bad. Pressure plates too. All needs to be replaced. Overrun clutch, also burnt, pretty bad, needs to be replaced. We're going to go to the forward clutch. Everything forward gears this clutch is on, first, second, third, and fourth, completely burnt. Really bad. Third gear clutch, which is also known as the direct clutch, burnt really bad. I actually even combed the steels, pressure plate, everything needs to be replaced. It's complete garbage. Now we'll go to the second gear. This is second gear clutches, extremely burnt. This one's almost metal to metal contact. Basically this clutch is right there. You can see that there's already metal to metal contact around the edges. Pressure plates, steels, clutches, all needs to be replaced as an assembly. When this clutch is burnt, it's an indication of very poor pressure control. The forward clutch is applied as soon as you put the car into a forward range, be it manual low, second, third, or fourth. It's not a shifting clutch. It turns on, it stays on until you actually take it out of a forward range. So when this clutch is burnt, it's an indication that there's just not enough pressure in the transmission to keep it held tight to prevent slippage. Again, this is controlled by the valve body. Alright, when you have that many clutches burnt inside the transmission, the biggest problem with it is pressure control. And what controls the pressure is the valve body. Through EPC solenoids, through a lot of the valves, shift solenoids, they don't actually control pressure, but they control shifting. If this isn't set up correctly, the transmission is destined to fail from the get-go. We found with this transmission regarding hydraulic pressure control is accumulator pistons. These are the factory pistons. There's no pin in this piston. However, there is a flat washer inside that won't come out. Here's another piston. Flat washer inside. This is recalibration of your transmission when you buy the competitor's transmission. It doesn't mean it's right. It just means it's a halfway attempt at trying to do something correct that didn't work. These pistons all have single O-rings on them. Another one that also has a washer inside. Single O-rings. These pistons aren't adequate to do the job of what we're trying to do with a high-performance, A340E in your Supra. What you need are billet pistons made by ATF. Multiple rings for sealing instead of Here's the difference between the two accumulator pistons. This being stock and this being ATF. Notice the extra sealing rings, the extra O-rings, which prevent a lot more rings, a lot better seal. Rings that actually stick out and actually compress when you install it in the bore. A lot of the Toyota factory pistons, the rings are very thin and you don't get very much compression, so as soon as the transmission gets hot, it starts leaking fluid past, creating slippage of the clutches or cross leaks, which can cause binds of clutches applying when they shouldn't be. So we do all the pistons, and now at the same time while we're doing this, we change the amount of accumulator travel by the amount of material we leave inside. So instead of using a flat washer, we just machine it to size of where we actually want it. So all of our pistons have been machined to make the transmission shift and feel the way that it should. It's not too firm, but it's not too soft. All right, this is the valve body off the Toyota A340E, and you could classify this as the actual brain of the transmission. This is the one that tells everything what it's going to do and when it's going to do it. The manual valve is connected to the shifter. That's what puts the actual thing in gear. But the rest of the valve body is what controls all the shifting, all the pressure control, the lockup torque converter. All that is controlled internally of the valve body through the computer system. This is very detrimental to the life of a performance transmission. If you want to have a performance transmission that's able to withstand, 800 horsepower or more, this valve body must be built correctly. So we do a lot of adjustments inside this valve body. This valve body, when we're done with it, is far from stock. We dyno test all of the solenoids individually, one by one. All right, on dyno and the solenoids, we have 5 solenoids in this transmission. We got accumulator pressure, we got lockup, and we got line pressure, and then we got 2 shift solenoids. All of these solenoids we dyno test on a solenoid dyno, individually by themselves. Then after that, we build the valve body to our specs with our modifications, our springs, everything that we do, and then we take the valve body as a whole assembly and we dyno the whole thing on a complete valve body dyno that gives us a computer system that we can actually plug into all the solenoids, and we can actually operate it on the dyno as a separate entity by itself. Now that we know this valve body works perfect, and we build the rest of the transmission, we put the valve body on the transmission, and then we dyno test the transmission as a complete assembly. So by the time you get your transmission, your electronics have been dyno tested, your valve body's been dyno tested, and the complete transmission's been dyno tested as one assembly. So you can be very confident that when we're done with it, your transmission is perfect. All right, here's your stock forward piston, which is made from cast aluminum, which is notorious for cracking when we increase the line pressure of the transmission. So our competitor has made a billet piston that's made a lot like the stock piston, and you can notice that in this area right here. This piston also is made out of a 6061 aluminum instead of a 7075. You can tell that by some of the coloring of the piston and the machining marks that are on it. Here's our piston that's made out of 7075. And what we did was we changed the design around the humps for the springs. And by leaving all of this material here, it makes the piston much thicker, which prevents it from cracking. Now this material in here has to be cut out to aid in clearance for the clutch hub. But this little bit of material that we left in here makes a big difference. All right, here is the billet second gear sprag assembly made by ATF. And you can notice that it's completely billet. The inner race is billet, uses a much larger sprag, and it's got a complete billet outer race. This inner race is pressed on to the original sun gear, TIG welded into position. Everything is heat treated. It's much stronger than a factory second gear sprag assembly. Inner race. Right, this is the inner race, which is part of the sun gear shaft of a factory Toyota A340E second gear sprag assembly. This inner race is really small, and the sprag is also really small to fit on it. At ATF, we manufacture a billet inner sprag race for second gear that presses on to the shaft and is TIG welded into position. This allows us to use a much larger sprag assembly, which gives us more holding capacity in second gear. If I was to remove this race and put our sprag assembly on, you would notice how much bigger our sprag actually is versus the stock one. This is a mandatory item on any performance-built A341E over 500 horsepower. Now it's on and running. So now we're on forward, clutch is on, so we're basically in first gear. So when I shift the second, you'll see the gauge go up to second. And when I shift the third, you'll see it go up for third. When I shift the fourth, you'll see it go up to fourth. And then when I kick lockup on, these gauges will actually flip. I'll do that from the computer. So now we're in first, we shift the second comes up, click the third comes up, now fourth, and then over here when we go into lockup, which will be one more, we drop the release side, the apply side come up, but I only have the duty cycle at 50.